أعزائي طلبة وطلبات شهادة الثانوية العامة قسم رياضيات، أهلا بكم. اليوم إن شاء الله سوف نتطرق إلى درس جديد في الجبر اسمه الصورة المثلثية للعدد المركب. Welcome my dear student in our math program for secondary 3. Today we are taking new lesson. It's titled Trigonometric form of complex number. Dear student, what you meaning of complex number? You mean complex number contains two terms. The first term is real, second term is imagined number. Today we are taking introduction about trigonometry form of complex number, log and deduce. Trigonometry form of complex number. Dear student, polar and Cartesian coordinates. We have two coordinates in polar and Cartesian. The opposite figure represent circle with radius length r. Point A, xy lies on a circle and opposite to angle of measure theta. Look at, dear student, we have point, its coordinate xy lies on x, lies on the circle, radius r, opposite angle theta, or the position vector of point xy inclined on a or x axis by angle theta. Cosine theta equal x over r, sine theta equals y over r. By cross multiplication, we find the value of x equals r cosine theta, also y equals r sine theta. Remember, dear student, if you have point lies on a circle, this point its coordinate x and y. The first x means is cosine, y is sine. Then cosine theta equal x over r. What is r? Square root x power 2 plus y power 2. If we find sine theta is y over r. If you find the value of x, we use cross multiplication r cosine theta, also y equal r sine theta, where r equal square root x power 2 plus y power 2. Also tan theta equals y over x, or sine over cosine. Remember, r is square root x power 2 plus y power 2, sum of two squares of two components of point x and y, also tan theta y over x. In this case, we find theta equal shift tan or tan negative 1 y over x. When tan theta, say, equal 45, we find theta equal shift tan for 45 equals 1. If tan theta equals 1, theta equals shift tan 1 equals 45. Then when we find theta, we find shift tan y over x to find the value of theta. Dear student, look at in a polar plane where the polar axis coincides on the positive part on x-axis. We can change polar coordinate to Cartesian and vice versa. Conversion polar coordinates to Cartesian coordinate. Now we are translate how to convert from polar to Cartesian and vice versa. If the point A in a polar coordinate is a r theta, then the Cartesian coordinate is r theta, where x equal r cosine theta, y r sine theta. Then r cosine theta, r sine theta is point x and y. Operation of the set complex number. Dear student, if we have z1 equal x1 plus I y1, this is complex number. Remember, dear student, complex number contains the first real, the second imagined. z2, another complex number, contains x2 plus I y2. Z if z1 equals z2 when x1 equals x2 or and y1 equals y2. What do you mean? When complex number, two complex number are equal, then real equal real and imagine equal imagine. Example, if we have two complex number are equal, left hand side x plus 3y, right hand side 4 minus yi. What is the value of x and y? Dear student, x equals 4, y equals negative 3. Why? Because the real in the first is x, the real in the second y. But imagine in the first 3, imagine in the second negative y. Then in this case, x equals 4, y equals negative 3. If we add two complex number, what is the result? We add real plus real and imagine plus imagine. If we have two complex number and we need to add complex number, we add real plus real and imagine plus imagine. Example, look at the student. If z1 equals 3 plus 2i, z2 3 plus I, then z1 plus z2 equals what? 3 plus 3 equals 6, 2 plus 1 equals 3i. Then when you add two complex number, the result is also complex number. Why? Because look at z1 plus z2, the result is 6 plus 3i. Then x 6 is real, 3i is imagine. When multiply two complex number, what you deduce? Look at the first, x1 plus I, y1, multiply, bracket contains x2 plus I, y2. First times first, second times second, mean times mean, extreme times extreme. Then the result is x1, x2, negative, y1 plus y2. This is real. But imagine x1, y2 plus x2, y1, this coefficient of I. Example, look at the student. If we have two complex number, z1 5 plus 2i, z2 3 plus 4i. What is that z1 plus times z2? Look at when we have two bracket, we have two bracket. The first bracket contains 5 plus 2i, second bracket contains 3 plus 4i. What is the product of the two brackets? First times first, second times second, mean times mean, extreme times extreme. What is the first times first? 15. Negative 2i times 4i, negative 8i power 2 also equals positive 8. What is the 2 means? 6i. What is the two extremes? 20i. When add 6i plus 20i equal 26i. This is imagine. Then the result is 15 minus 8 plus 20 plus 6i. Answer is 7 plus 26i. When multiply z1 times z2, two complex number, answer must be complex except two numbers are conjugate to other. If z1 and z2 are conjugate, then the product of two of them must be real number. Dear student, another solution, if we have z1, z2, bracket contains 5 plus 2i, times bracket contains 3 plus 4i, we multiply first times first 15, 2 extreme 20i, 2 means 6i, second times second 8i power 2, I power 2 equals negative 1, then answer is 15 plus 26i negative 8, answer is 7 plus 26i. Now we are translate to another title. It's called conjugate of the complex number z is z bar. If we have z equals complex number x plus yi, what is its conjugate? Conjugate is x minus 4 z bar equal x minus yi. Dear student, in this problems, very important properties. If we have two complex number, the first is z1 equal x plus yi. conjugate is x minus yi. When we add two conjugate numbers, the answer is real. Why? Because, as example, if we have x equal 3 plus 2i, what is its conjugate? 3 minus 2i. When we add 3 plus 2i plus 3 minus 2i, we simplify 2 equal 6. This real number. Also, when multiply number by multiply its conjugate, must be the result is real number. Remark, dear student, when we add or multiply any two conjugate number, the result must be a real number. Conjugate of the complex number, the first is zx plus yi, x bar or its conjugate is x minus yi. Remember, dear student, in conjugate number we change the sign of imagine only. Look at x plus yi, but x minus yi, what you note? We note that we change the sign of imagine term. Now we are translate two properties of conjugate values. Dear student, if we add complex number and its conjugate is a real number. Example, if we have z equals 3 negative 4i, then z bar equals or conjugate is 3 plus 4i. When we add 3 plus its conjugate, z1 plus z2 conjugate, answer is 3 minus 4i plus 3 plus 4i, answer is real number, 6 belongs to R. If we multiply z1 times its conjugate, also is a real number. Look at the example. If we have z equals 2 plus I, then what is the z bar or conjugate equals 2 minus I. Change the term of imagine. When multiply z by its conjugate, answer is 2 times 2, 4. I times negative I power 2. What is the value of I power 2? Negative 1. 4 negative negative 1 equal 5. 4 positive 1 equals 5. This number belongs also to R. Sum conjugate of, remember, dear student, conjugate of two complex. What is the result? Yes, sum of two conjugate. Remember, dear student, conjugate of to add two complex equal sum of each conjugate. Again, dear student, conjugate of two complex equals sum of two conjugate of two complex. Example, let z equals 2 plus 3i, z2 1 minus I. When we add z1 plus z2, 2 plus 3i plus 1 minus I, answer is 3 plus 2i. What is the conjugate of z1 plus z2? Change the sign, 3 minus 2i. This equation number 1. Since z1 equal 2 minus 3i, its conjugate, z2 also 1 plus I, we have conjugate of the first plus conjugate of the second. Answer must be equal 3 minus 2i. What you deduce? Excellent student. When we find conjugate of two complex number, the result is sum of two conjugate numbers. From 1 and 2 we get conjugate of z1 plus z2 equal conjugate of the first plus conjugate of the second. Conjugate of product of two complex equals what? Product of two conjugate. Example, dear student, if we have z1 1 plus I, z2 3 plus 2i, the first z1 times z2, Look at Z1 contains 1 plus I, Z2 3 plus 2I. We find first times first, second times second, mean times mean, extreme times extreme. Or 1 times 3 equals 3, I times 2I negative 2. Why? Because I times I squared. I power 2 equal negative 1. Negative 1 times 2, negative 2. Also, what is the product of 2 means 3I. What is the product of two extremes, 2I? Adding 3I plus 2I equal 5I. Answer is 3 plus 2I plus 3I plus 2I power 2 equals 1 plus 5I. When multiply Z1 times Z2, answer is complex number 1 plus 5I. What is the conjugate of Z1 dot Z2? 1 negative 5I. Why? Because when conjugate, we change the sign of the imagined only. 1 plus 5I, its conjugate 1 minus 5I. Z1 equals 1 minus I. Z1 conjugate. Conjugate Z2, 3 minus 2I. Then we multiply conjugate of the first times conjugate of the second. Conjugate of the first, 1 minus I, multiply conjugate of second, 3 minus 2I, also equal 3 minus 5I plus 2I squared. Why? Because first times first equals 3. 2 means equals negative 3I. 2 extreme negative 2I, its sum negative 5I. Look at the second times second, 2I power 2. 2I power 2 must be negative 2. Answer is 1 negative 5I. What to deduce? When find conjugate of product of two complex equal product of its two conjugate. From 1 and 2, we deduce that conjugate of product of two complex number equal product of its conjugate. If we have Z1 equals Z2, then conjugate equals its conjugate. If Z equals Z1 times Z2, then conjugate equal conjugate of the first times conjugate of the second. If we have Z equals Z1 over Z2, its conjugate also equal conjugate of the first over conjugate of the second. Now we are translate to solve problems. Simplify. Look at the student. I power 20 plus I power 25 plus I power 30 plus I power 35. We know that I power 20 equals 1. Why? Because any number divisible by 4 equals 1. Dear student, imagine number is very important number. Why? Because I power 4 equals 1. Any I power number divisible by 4 equals 1. Remember, I equals square root negative 1. What is the I? Look at x power 2 plus 1 equals 0. When x power 2 equals negative 1, then x equals positive or negative square root negative 1. We know that square root negative 1 equals I. What is the meaning of the I? Imagine number. I square equals negative 1. I power 3 equals negative I. But I power 4 equals 1. Then we deduce that any I power number divisible by 4 also equals 1. I power number divisible by 2 also equals negative 1. In this problem, we substitution about I power 20 is I power 4. Why? Because 20 equals 4 times 5. I power 20 equal I power 4 for all power 5 also equals 1 power 5 equals 1. Then we deduce that any number power divisible by 4 also equals 1. Dear student, look at the solution. I power 20 also equals 1. Why? Because 20 divisible by 4. I power 24 equals I power 24. I power 25 equals I power 24 times I power 1. But I power 24 equals 1. Then I power 25 equals I. But I power 30 equal I power 28 times I power 2. I power 28 equals 1, but I power 2 equals negative 1. Also, I power 35 equals I power 32 times I power 3 equals negative I. Look at I power 20 equals 1, I power 25 equals I power 3 equals negative 1, but I power 35 negative I, then 1 negative 1, 0, I negative I equals 0, then simplify equal 0. Look at second. Simplify 1 over I plus 3 over I power 3 plus 5 over I power 5 plus 7 over I power 7. I equals 1 over I first term, 1 equal I power 4. I power 4 over I power 3. We put 3I power 4 over I power 3 equal 3I. Also 5I power 8 over I power 5 equals 5I power 3 equals negative 5I. 7 over I power 7 becomes 7I power 8 over I power 7 equals 7I. I power negative 1 plus 3 I power negative 3 plus 5 power I power negative 5 plus 7 power I power negative 7. Then I power 3 equals I power 3 plus I 3I plus 5I power 3 plus 7I. We add, then answer I power 3 negative I, 3I, 5I power 3 negative 5, 7I. We add or simplify. Answer is 4I. Dear student, expand 2 minus I for all power 4. At the first, we find 2 minus I for all power 2. After that, the result for all power 2. Remember, dear student, any bracket contains power 4. We find the bracket, the first bracket contains power 2, and we find the bracket for all power 2. Bracket power 2, we find the result of bracket power 2 as a method. First power 2 plus second power 2 plus first times second times 2. After that, we find the simplify. Then we find the result of for all power 2. The first power 2 for second power 2, I power 2. First times second times 2, negative 4I. For all power 2, remember I power 2 equals negative 1. Then answer 3 minus 4I for all power 2. After that, we find the result of bracket contains 3 minus 4I for all power 2 by 3 power 2, 9, negative 4I power 2 equals 16I power 2. First times second times 2 equals negative 24I. Answer is 9 minus 24I plus 16I power 2. Remember I power 2 negative 1. Then answer is 9 minus 24I negative 16. Answer is negative 7, negative 24I. Find in the form a plus bi z 3 minus 7i 5 negative 2i. Look at the solution. By multiply, if we have z equals 3 minus 7i 5 negative 2i, by multiply conjugate of its denominator. What is the conjugate of denominator? X and student 5 plus 2i up and down. We multiply up and down 5 plus 2i. Answer is, look at the numerator, 15 plus 6i minus 35i negative 14i power 2 over 25 multiply negative 14i power 2. When multiply, dear student, in denominator, complex number by its conjugate, multiply first times first, second times second only. Why? Because when simplify 2 means and 2 extreme equals 0. Then first times first equals what? Equal 25. Second times second, negative 14i power 2. Answer is numerator 15 minus 29i plus 14 over 25 plus 4. Then z equals, look at 29, negative 29. I in numerator over 29. We have common factor from numerator 29. Then 29 over 29 negative 29 over 29i, then z equals what? Z equals 1 minus I. Dear student, look at another example. If we have z equals 7 minus I over 2 minus I, find conjugate of z. Remember what you mean of the conjugate of z. Conjugate of z, when we have complex number x plus yi, its conjugate x minus yi. Look at the solution. When you have z equals 7 minus I over 2 minus I. What is wrong? This complex number, its denominator 2 minus I. We find simplify of z by multiply its conjugate 2 plus I up and down. Look at multiply 2 plus I up, 2 plus I down. Remember, dear student, when multiply in denominator 2 minus I, multiply 2 plus I, we multiply first times first, second times second. First times first 4, I times I, negative I power 2, negative I power 2 equals positive 1. Denominator becomes 5. But look at the numerator. When multiply 7 times 2, 14, 7 times I, 7i, negative I times 2, negative 2i, negative I times I, negative I power 2. In denominator 4 minus I power 2. Look at I power 2, remember, equals negative 1. Then z equals, in numerator, 14 plus 5i plus 1. Why? Because we simplify 7i minus 2i equals 5i. Negative I power 2 equals positive 1. In denominator equals 4 plus 1 equals 5. Then z is equals, look at 15 plus 5i over 5. Look at in numerator, we can find highest common factor is 5. Z equals 5 multiply 3 plus I over 5. Then what is the value of z? Z is 3 plus I. Then z equal 3 plus I. What is the conjugate? 3 minus I is conjugate of z. Remember, dear student, when we find conjugate of complex number, this number contains numerator and denominator. At the first, we simplify from, or we reduce, or we removing the denominator of the complex number by using multiply by conjugate of its denominator. Remember, conjugate of denominator, this number, we change the sign of imagined term only. After that, we find the simplify of z, z equal 3 plus I, then z bar equal 3 minus I. Remember, dear student, when multiply z times z bar equals 3 times 3, 9, I times negative I power 2. What is the negative I power 2 equals? Yes, positive 1. Then when multiply z times conjugate of z is answer is 10. Why? 3 times 3, 9, positive 1, 10. When we add z plus its conjugate, we add 3 plus 3 equals 6. I negative I 0. Then we deduce that when we add or multiply z with and its conjugate, in addition, the number must be belongs to R, not complex. Any complex, when we add its conjugate, the result must be real number. Also, when multiply any complex multiply by its conjugate, the number must be belongs to R or real numbers. Dear student, by the end of the lesson, I am very happy to spend such time with you. Remember, math simple, think, work, produce. Goodbye.